Student, last class I discussed about the open circuit test of a single phase transformer. Now I discuss about the short circuit test of single phase transformer. This is the circuit diagram. Here all the instrument, that is ammeter, voltmeter and wattmeter, connected in high voltage side, and remember that at now the low voltage side is short circuited. Low voltage side is short circuited. Now with the help of auto transformer, the applied voltage so adjusted that the circulate only rated high voltage side current. Here requirement of voltage is very small because at now the low voltage side is short circuited. Very small amount of voltage must circulate the rated current of high voltage side. The voltage is about 2 to 12% of rated value. That is the sufficient value, that is 2 to 12% of rated value to circulate the rated current of high voltage side. Now what should be the equivalent circuit of single phase transformer at now? That is, first I draw primary side resistance R1, primary side leakage reactance X1, shunt branch resistance RC, shunt branch reactance Xm, secondary side resistance R2, secondary side leakage reactance X2, and the secondary side at now is short circuited. Okay, so this is the equivalent circuit at now. This is the equivalent circuit in short circuit test. Now about half of the applied voltage, that is 1 to 6%, appears across the secondary leakage impedance. Therefore the exciting branch appear across the voltage, that is 1 to 6%. Now the core flux induce a voltage, that value is 1 to 6% also. Okay, as the voltage appear across the shunt branch about 1 to 6%, that means the core flux is about 1 to 6% of rated core flux. Again, we know that the core flux is proportional to the core loss. Again we know that core loss is proportional to the square of core flux. That is, the value should be 0.01%. That means 1 by 100 into 1 by 100 into 100 to 0.36%, that is 6 by 100 into 6 by 100 into 100 of the rated value okay. So core loss is very negligible. Because it is about 0.01 to 0.36 of rated value. So and now wattmeter show only the ohmic loss, as the core loss is very negligible. Again we know that at rated voltage the exciting current is 2 to 6% of full load, when voltage appears across the shunt branch it is about 1 to 6%, so that the exciting current must vary 0.02 to 0.36 of its rated value. As this value is very small, so we can neglect the shunt branch also. As the shunt branch is neglected, the equivalent circuit at short circuit test looks like this is your R1, this is X1. Okay, we are neglecting the shunt branch, so that there should be the R2, this is X2, secondary side is short circuited. Okay, this is the secondary side is short circuit. Now if the applied voltage is VSC in primary side and current flow through this circuit I of SC, then here VSC is the voltmeter record and ISC is the ammeter record. And suppose wattmeter record, that is ohmic loss, is suppose P of SC. Now the equivalent impedance referred to HV side, equivalent impedance referred to HV side is written as ZEH, nothing but VSC by I of SC. Now similarly, equivalent resistance referred to HV side is written as REH, that is nothing but PSC divided by ISC square. So from this two value we can simply write the equivalent reactance referred to HV side is nothing but root over of ZEH square minus REH square. Now the resistance R1 R2, that is primary side and secondary side, is nothing but half of RE, and reactance X1 X2 primary and secondary, that is half of XE. This is referred to the same side. Okay, so short circuit test, from short circuit test we know that gives that number one, ohmic loss, number two, the equivalent resistance and reactance. Okay, so these are two we know from the short circuit test of the transformer. Again, the voltage regulation of a transformer can be determined from the short circuit test, and from the data of short circuit test and open circuit test we calculate the transformer efficiency. Student, this is the short circuit test. If you have any query, please contact me. Thank you.